All right, here's our last topic in the Laws of Exponents Unit. We're going to look at division properties of exponents. So let's look at our table first. In our first row, we have 2 to the third divided by 2 to the second, which is 2 times 2 times 2 divided by 2 times 2. And I'm going to cancel out common factors here. And when I do that, I'm just left with 2. Next one says 2 to the 7th divided by 2 to the 4th. So we have 2 times 2 times 2 times 2, 2 times 2, let's see, 1, 2, 3, 4, 5, 6, 7, divided by 2 to the 4th. Again, let's cross out common factors. And I'm left with 2 times 2 times 2, or 2 to the 3rd. Next one we have 2 to the 5th. Divided by 2, cross out common factors, I'm left with 2 to the 4th. And finally 2 to the 3rd, divided by 2 to the 6th, cross out common factors, I'm left with 1 on the top and 3 2's in the bottom. So our shortcut for dividing powers with the same base is that we can subtract our exponents. So a to the m divided by a to the n equals a to the m minus n. Notice it's our exponent in the numerator minus the exponent in the denominator. So down below, 5 to the 10th divided by 5 to the 3rd would be 5 to the 10 minus 3, or 5 to the 7th. X squared divided by x to the 8th would be x to the 2 minus 8, which gives us x to the negative 6, which is rewritten as 1 over x to the 6th. So if we want to simplify an algebraic expression with exponents, we can take x to the 9th divided by x to the 3rd, which would be 9 minus 3, or x to the 6th. In number 2, we can combine like terms. So for my p's, I'll take 3 minus 6 and get negative 3. And for the q's, I'll take 4 minus 1. Remember that q has a power of 1, and get q to the 3rd. I'm going to rewrite that so my final answer has positive exponents. In number 3, now same idea, I'm subtracting, so I'm taking x to the 4 minus negative 2, which will become plus a positive, and I will get x to the 6th. So be careful of your signs. In number 4, we'll take, for the a's, 5 minus 9 and get negative 4. In the b's, negative 3 minus negative 9 will give me a b to the 6th. And rewriting that so we have positive exponents in our final answer. So raising a quotient to a power is similar to the power product rule in that everything in parentheses gets the exponent. So a divided by b to the n is the same as a to the n divided by b to the n. Example of this, 3 divided by 4 raised to the second power is the same as 3 to the second divided by 4 to the second, or 9 divided by 16. So let's look at some examples of simplifying a power raised to a power. In number 1, everything is going to get that exponent of 3. And remember, whenever we raise a power to a power, we're going to multiply. So that means I'll have x to the 6th, y to the 3rd, divided by z to the 15th. I cannot simplify any of those, so that's my answer. In number 2, again, so I'm going to distribute the exponent of 7 to everything in parentheses. Of x to the negative 35th divided by y to the 21st, z to the 14th. Can't leave a negative in my final answer, or I should say a negative exponent in my final answer. So I'm going to rewrite that as 1 over x to the 35th, y to the 21st, z to the 14th. All right, when we're raising a quotient to a negative power, the easiest thing to do would be to make that exponent outside positive first. So if we have a divided by b raised to the negative n, then I can flip what's inside the parentheses. So notice it became b divided by a, and then that exponent outside the parentheses becomes positive. It does not change anything inside the parentheses. So for example, x to the third divided by y to the fifth raised to -6th power. So if I flip my fraction inside, my exponent outside becomes positive, and then I can just distribute like I would and get y to the 30th divided by x to the 18th. All right, let's look at two last examples, simplifying a power raised to a power where the exponents outside are negative. So first thing, we want to make this -3 into a +3. So I'm going to flip my fraction inside, and that will make that 3 positive. Then distribute that exponent of 3 to everything inside, and look to see if we can simplify anything, and we can't, so there's our final answer. Same idea number 4. Let's make this -4 positive. So let's flip our fraction. Notice it does not change my exponents inside. It's only changing that power outside. And then distribute everything. So we will get k to the 16th, m to -4, over 5 to the 4th, j to the 24th. And I'm going to bring that m into the denominator to change its power to a positive exponent. And that's my final answer. All right, go ahead and work on the division properties of exponents practice worksheet.